All right, so hello, welcome to class. Monday, April 13th. Um, so a few things I want to go through before we start getting into this. Um, the first thing, if you haven't done the assignment yet, then stop watching the video, go through, try to do the assignment without looking at the key, and then you can watch the video or look at the key. The second thing, grades, we still haven't gotten any real official guidance from the district yet. So for the moment, um, your grade book for cycle 5 is still open. So if you have any late work from last cycle, get that in and I can get those grades in. Um, I've been trying to contact people who aren't doing as well, but it also really helps if you try to contact people. So if you know friends or anyone who you're pretty sure isn't working, try to contact them. Or just even people who you wouldn't necessarily call your friend, maybe just someone you know from class where you happen to have their number or contact information from labs. I could really use your help getting out to those people. Um, yeah, if you're just watching this and you have a lot of late work or things not turned in, just please get in whatever you have because it's a lot easier to work with your grade if you've turned in your work than if I don't see any work. So if I see that you've been getting things turned in and you have the big grades in, especially like tests and labs, like the not Thanksgiving, spring break test or the test we had here. If you have those in, it's a lot easier to justify moving your grade, and I can say, oh, you've been participating and I can move it. But if you don't have things turned in, it's a lot harder for me to improve your grade. So just please, if that's you, please be trying to get things in, or anyone you know in any of the classes, anyone you have like contact information for, I could really use your help getting out to them and just giving them the message that as long as they're turning things in and they get the majority of things in and I see they're working, I can get them to passing. All right. So there's that. The other thing is I'm starting to try to put together, it's probably not going to be just completely a mock test. I mean, I'm putting together something like that. That'll probably be out either Wednesday or Friday. But yeah, I'm going to make a kind of pseudo mock test that is going to try to replicate what it sounds like the AP test will be. So keep an eye out for that. There will probably be something like that coming up this week. And yeah, there'll be some sort of system of randomizing everything again. So keep an eye out for that. Am I missing anything? I don't think so. Yeah, in about a month until the AP test. So just keep working, keep going through this, and then you'll be kind of done with this. And you'll take the AP test, and I'm going to go kind of easy on you. Probably still going to teach a few things we missed, but not in a whole lot of depth. All right, so let's get into our questions. Again, the AP test this year is going to only be 2 questions. It sounds a lot like on this year's AP test because we only have the 2 questions and we have 7 different topics to go through. It sounds like each question is going to have a lot of topics within the question. And it also sounds like they're going to try to make the test a lot more where each part can be solved separately. So it's going to be in your best interest to kind of look around. So it sounds like they're going to do it to where like one part talks about projectile motion, the next part talks about energy, the next part talks about forces, something like that. And in order to get a really good test of your understanding, they kind of have to make the parts really separate from each other. So it sounds like this year, more so than previous years, it's going to be really, really good to jump through the question. You might not know how to do A, but it sounds like B is going to be completely separate and easy to solve. So on your test, try to skip through that. It'll be the best, and you might be able to get some points there. But yeah, don't kind of just get to a point, I don't know what this part is, and then ignore the rest. So yeah, it sounds like you're going to have that. You'll have 25 minutes on the first question. So you're not going to have an experimental design question like this one that we're doing right now. But the rest of the question is still really good, and there's a lot of things we can still get out of it. So I'm not going to focus too much on the procedure, but the rest of the question is a really good question. All right, so going through this 25-minute question. Again, your first question is going to be 25 minutes. So I would practice actually timing yourself for these and then see how it goes, and then you'll have 5 minutes to upload after that. You should have access to a practice test by the end of April, and I'll put it out and you can go there and actually practice going through this. All right, so we have here a student wants to determine the coefficient of static friction between a long, flat wood board and a small wood block. So A, we want to describe an experiment for determining the coefficient of static friction between the wood board and the wood block and assume equipment usually, and assume that we have all the normal equipment from a School of Physics laboratory. So I mean, things we normally use like scales, meter sticks, timers, nothing crazy. So 1 and 2 are kind of split up. So 1 wants us to draw a diagram of the experimental setup of the wooden block, and the diagram indicate each quantity that would be measured and draw or state what equipment would be used to measure each quantity. I would do both, draw it and label it. So what would we do for this one? What setup could we do to find coefficient of static friction? There's a few ways of going about it. Well, we did a lab at the beginning of the year, if you remember that, kind of, not the complete beginning, but towards the beginning, where we had this, we had a block right here, block, or wood board, whatever you want to call that. Probably use the words they use. Let's call this a board. And we can do this where we have, remember our little spring scale. So we can use this to get how much force we're pulling with. And then we can also include a triple beam balance. So that's one way of going through this. So that's what we did at the beginning of the year. And there's a lot of different ways of going about this. Some people have done this in the past where they have like a pulley right here, and then they hang a mass here, and then that replaces the spring scale. So a few ways we could go about it. This is the way we did earlier in the year. So this is one way. And then we have another way, which is what they made the key in order to do. Is another way we could do this is have the board on a ramp and then tilt this up to a certain angle theta, and then we can use a protractor in order to get the angle. All right, so again, not going to focus too much on this because this part won't be on the AP test. However, doing the math for one of these could easily be on there. They could easily give you one of these and say, find the coefficient of friction. All right, so we want to describe the overall general procedure, including any steps necessary to reduce experimental uncertainty, give enough detail that another student can replicate the experiment. So we'll call this the first way, we'll call this the second way. So if we did this the first way, we could just pull mass, probably call it the board horizontally. Horizontally with the spring scale. And measure the maximum force before the block moves. Now, we can talk about actually getting the mass of this, but we're going to see eventually the mass is going to end up not mattering. So we could say measure the mass with the triple beam balance, but it won't actually end up mattering. So I'm actually going to cross that out. So this would be A. And then B would ask us to derive the coefficient of static friction. So that means we're probably using our magnitude of force of friction less than or equal to the coefficient of friction times magnitude of normal force. Now, normally this less than is not moving. Yeah, we are going to assume this is on Earth. Any of these questions, if they don't say otherwise, you're on Earth. They'll be explicit if you're not on Earth. They'll say something like an object is not on Earth or on Mars or on the moon. But if they just say you're a student and what's to determine the coefficient of static friction, that student's on Earth. All right, less than or equal to. Normally less than is dealing with not moving, right? This is not moving, it's static friction. Yeah, how is it equal to, even though this is static friction? It will be UMG, but it's going to be equal to, it's not moving, but it's about to move. So that all goes back to we're pulling with the maximum possible force before the block moves. All right, so that means this is about to move when we get there. That means we can use our equal sign. So we have our free body diagram. So like you said, why the normal force and weight are going to be balanced. So my normal force is equal to my weight. So that's how you're getting force of friction is coefficient of static friction times mass times acceleration due to gravity. Now, if we're pulling this just enough to move, we're going to have an applied force this way is going to be balanced out by our frictional force this way. Now, again, this is just starting to move. So in reality, this applied force is just this tiny, tiny amount bigger than our frictional force. So if you want to be really precise, it's going to be applied force plus some tiny extra amount in order to overcome friction. But we're looking for the minimum, so we're pretty much just going to say these two are equal. All right. So our frictional force is going to be balanced out by that applied force. So we're measuring that applied force from the spring scale. So we'll say FA is equal to force measured by spring scale. And I was actually wrong. I was thinking ahead and I ended up kind of messing up a little bit. So our applied force is equal to our frictional force. So I know my applied force is equal to the coefficient of static friction times mass times acceleration due to gravity. That means our coefficient of static friction would be that applied force pulled on by the spring divided by mass times acceleration due to gravity, which means we really do need to include the triple beam balance. So we need to measure mass of the board with the balance. I was thinking ahead to if we were getting acceleration, the masses would divide out. Force scale. So a lot of times I would say like an electronic scale, something like that. You don't have to call it or force scale. I would be specific what you mean by force scale. There's several ways of doing this. There's electronic force sensors. So if you're going to call it something, I would either call it a spring scale or an electronic force sensor. Force scale can mean a lot of different things. So yeah, normally the word spring scale or electronic force sensor. And then we did miss something from the procedure. Again, since procedures aren't super important for this test, I'll just tell you what it is. It says including steps to reduce experimental uncertainty. So to reduce uncertainty, this means we would repeat multiple trials for the same mass. So, all right. I hear my cat wandering in, sneezing everywhere because the weather changed again. So that's one way of doing this. Or we can do our alternate way. This is the second way of doing this, which is what they're expecting us to do on this test. So the other way was put our board on this ramp. Put board on ramp. Increase angle until block is just about to move. So any greater angle causes the block to move. Then we can measure the angle with a protractor. All right, so let's go through and look at this. So let's try to do B where we actually calculate the value. So we're going to start with a free body diagram. So I have the mass on a board. I have the weight down. The weight is going to be bigger than my normal force, right? Because the ramp doesn't have to hold up the entire weight. Some of the weight is pulling down the ramp. And we're going to have friction holding us up the ramp. And then our angle theta right here that we're measuring with a protractor. So we're going to have to split this up into a force resolution diagram. What part is down the ramp, sine or cosine? Yeah, sine slides down the ramp. So I have force of friction up the ramp is going to be exactly balanced with the weight times sine of the angle down the ramp. Weight times cosine of the angle into the ramp is going to be balanced with my normal force. And again, we're pulling this until just about to move. So if I move this to a greater angle, then this will slide down the ramp. So sine slides down the ramp. So because this is about to move but not quite moving, I know my normal force. Well, normal force is always just going to be that mg cosine of the angle, but my frictional force is going to be the weight times sine of the angle. These are just barely balanced before any greater angle. This weight sine angle is going to overcome the frictional force. Well, again, that frictional force is going to be equal to the coefficient of static friction times my normal force, equal to, again, because this is the maximum angle just before sliding, so equal to because this is just about to slide. So I can put my two values in here. My force of friction is going to be mass times acceleration due to gravity times sine of the angle of the ramp. And again, I should really probably call this the angle max. This is the maximum angle before the block slide. This isn't just any angle, right? This is very specifically the angle right before this block starts to move. All right, coefficient of static friction. My normal force is this, mass times acceleration due to gravity times cosine of the angle max. Well, mass and acceleration due to gravity divide out from both sides. I can divide cosine over. What's sine divided by cosine? Sine divided by cosine is tangent of that maximum angle before this thing slides. So my coefficient of static friction is going to be tangent times that maximum angle. And this is actually really important. It's not tangent times any angle for the ramp. This is tangent times the maximum angle I move the ramp to before this thing slides. Very important difference. So all I need to measure is that angle. So that's good. I've got enough information to measure my angle. But again, I need to talk about reducing experimental uncertainty. So repeat for 5 trials with the same mass. That way we do this a lot of different times and we can see if our results are the same. So we can do the 5 trials and just look at the results, or do the 5 trials and average them. So let's see the points we get. Again, don't care so much about the points for experimental design, care more about the points for the math and everything. So no, the coefficient of static friction is going to stay the same for the surface between the wood board and the surface. That angle is the maximum angle before this thing slides. So we're going to see, I don't care about the angle before it slides. I just care about the angle once it gets to the point where it slides. So notice they're saying measure the angle theta at which the block starts to slide with a protractor. So I don't care about just any angle. I care the angle in this equation is only the angle when this is about to slide, so that coefficient of friction is not changing. All right, so drawing an experimental setup to measure the coefficient of friction that is feasible in the School of Physics lab. So either one of the ones I showed work. There's other ways of doing this. If you have a non-standard way, you can ask me if you got the points. If you didn't, choose one of those two. Indicating any measurements needed. So for this one, you just need to measure the angle. For the first one I did, you need to measure the mass and the applied force. And then indicating equipment necessary for measuring quantities required to calculate coefficient of friction. So yeah, as long as you said what equipment you needed to make what measurements. So if you just said measure the angle, you would get this point. But if you didn't say measure the angle with a protractor, you don't get that point. All right. 2 is your description of how you'd measure it. So you need to have something consistent with the diagram. So if your diagram is completely different from what you're saying, you don't get this point. You need enough detail that someone could replicate the experiment. So if you're just like, measure angle for a block, that's not enough detail. So this is a little bit kind of, you have to interpret your answer. A good way of seeing if you have enough information would be to probably ask another student to look at it for you, and they can tell you if they understand what you're saying or not. Because of course it makes sense to you. You wrote it, but if you ask someone else, does it make sense? They can tell you pretty easily. The description is valid to find quantities, so you got enough information to actually measure the quantities, and then reducing experimental errors, so talking about multiple trials. Again, don't care so much about that. So in order to earn all credit for B, all terms must be indicated in the diagram and or procedure. So here, this is saying you have to have talked about measuring the quantities here. So if you didn't talk about measuring the quantities there, you don't get the point. So using Newton's second law, so Newton's second law, F equals ma, net force equals mass times acceleration, in one dimension parallel to the board's surface, either explicitly or implicitly. So all term variables must be indicated. So, yeah. So we didn't actually set up F equals ma, right? But we did use Newton's second law by using net force. For both of our situations, our net force was 0, which meant our forces were balanced. So we used Newton's second law implicitly. I never sat down and said net force equals mass times acceleration. So I didn't go through all this where I didn't say like F net equals ma. Well, net force equals mass times acceleration. My acceleration is 0, so I didn't go through all of that. Acceleration 0, 0 newtons. Therefore, my force has to be balanced. So I didn't explicitly go through all that, but I did implicitly. So I would say I get the point. Using Newton's second law, or reasoning in terms of net force is 0 in one dimension perpendicular to the board surface, either explicitly or implicitly. So yeah, so going through and replacing values in the equation. So yeah, replacing normal force with mg is implicit use of Newton's second law, because you're saying that the net force in that direction is 0. So yeah, so an appropriate trigonometry, if you use an angle, you need get the cosine correct, things like that. And then correctly deriving your expression. So setting up your Newton's second law in order to get this, yeah, that would be the point. So a lot of different ways to do B. Your test isn't going to be quite like that. It's probably going to be a lot more specific. All right, C. I like C. C is an interesting question, and I could easily see them asking you a question like this, even though you don't have an experiment question. I could easily see them giving you data to look at and see if it makes sense. So a physics class consisting of 6 lab groups wants to test the hypothesis that the coefficient of static friction between the board and the block equals the coefficient of kinetic friction between the board and the block. So we know that these are different. We know that normally that coefficient of static friction is bigger than the coefficient of kinetic friction, right? It's a lot harder to get something to start moving than to keep it moving. This is why if you ever try to push something really, really heavy, you're having trouble moving it. But the second it moves, it kind of jolts forward and slides pretty fast. So really hard to get things moving, a little bit easier to keep them moving. Each group determines coefficient of kinetic friction, so all the different groups go through, get their data here. The group's results are shown below with the class averages indicated in the bottom row. So based on the data, what conclusion should the students make about the hypothesis that the coefficients of static and kinetic friction are equal? Well, it looks like they're equal here, right? So does our conclusion match the fact that the coefficient of static and kinetic friction are equal? Yes or no? You think no. Okay, yeah, the answer is no. The averages look good, but what group here sucks at doing labs? No, no need to call out people by name. Group 5 over here. If you'll let me actually highlight this. Yeah, group 5, they kind of suck at doing labs. I'll let you think of who is group 5, or if you're normally part of group 5. I'm not going to call out people. But yeah, this group here, everyone else 0.45, 0.46, 0.42, pretty constant. 0.7 something, they're pretty terrible. These are all like 0.5 somethings, and then you have a 0.23 in here. So yeah, group 5, I think they need to go and redo their lab. They did not do something right. So yeah, so looking at this, if I remove this data, if I remove group 5 because their data looks horrible, what's going to happen? Is the coefficient of kinetic friction equal to or less than? Yeah, your average is going to change, so which one's going to be bigger, kinetic or static friction? Yeah, so we're going to have a bigger coefficient of static friction, a smaller coefficient of kinetic friction. So based on the data, I would argue, don't worry about that. I would argue that the coefficient of static and kinetic friction are not equal. So they're not equal. That's what we would select. And justifying my reasoning, I would say something like group 5 sucks at doing labs. Or you probably shouldn't write something like that. We could look at group 5's data seems like an outlier. Is probably a little bit better way of putting that. So group 5's data seems like an outlier. When looking at the other groups only, it appears that the coefficient of static friction is greater than the coefficient of kinetic friction. So something talking about how we need to remove group 5's data. When we remove group 5, I I think they would still give you point if you wrote this instead of that. Group five's data seems like an outlier. I think if you wrote group five sucks at doing labs, you would probably get that point. Um, it wouldn't be the worst thing I've ever written on any AP test I took. I always had fun with questions on the AP test when I didn't know what to write for an answer. I still somehow passed that biology test. C. So correct answers, they are not equal. So you cannot earn any credit if you select the incorrect answer. Now again, notice the wording here, reasoning cannot earn credit if the incorrect selection is made. So here's where it's kind of, when you're selecting these answers, if you're unsure, don't check a box. It says you can't earn credit if you select the incorrect answer. So if you don't know what you're thinking, if you don't know which is correct, just don't select an answer. Just go through and write some sentences. Only select that answer, only check the correct box if you're really confident that's the correct one. So if you're uncertain, does it change or doesn't it change, then just don't select something and then write something below it. If you're certain about one, then select it and then answer it. So if you're really certain, then select the box. If you're not certain, don't select it. Otherwise, you might be removing yourself from points. So identifying group five's data as outliers or indicating the presence of an outlier. So I would say if you said group five's data sucks, I would say that gets that point. For a conclusion that the coefficients are not the same, justified by either removing the outlier or notifying the coefficients are different for each group. So that would be just something like if I were to go through and average the data without group five's information, I would see that the coefficients of friction are not the same. Now, on to possibly my favorite answer out of any question on any AP test I've ever seen. All right, a metal disc is glued to the top of a wood block. The mass of the wood of the block system is twice the mass of the original block. Does the coefficient of static friction between the bottom of the block and the board increase, decrease, or remain the same when the disc is added to the block? Now, I'm going to use kind of this perfect physics world. So pretty much like everything we do, this perfect physics world, things are approximated, like no air resistance, strings don't stretch, strings don't have mass. We're also going to say that the coefficient of friction is only determined by the two surfaces. So we're going to say, therefore, the surfaces don't change, and that coefficient of, it's just asking coefficient of static friction, therefore the coefficient of static friction is unchanged. So I would say remains the same. And here's why this is my favorite answer out of all of these. So you could have selected any of these. So we chose remains the same because the coefficient does not depend on the math, or it only depends on the two surfaces. So we could see, based on our equation from here, we saw our mass cancels out, our mass divides out, and that won't change. If we use this equation, you might be tempted to say bigger mass. Well, I'm dividing by a bigger number, so I get a smaller coefficient of friction. But that's not the whole story, because if I put a bigger mass, that means I'm going to have to apply a bigger applied force. So my applied force will change as I change the mass here. So it's a little bit easier to see on this equation where our mass divides out. That mass has no effect. So that's one way of going through it. Or you could say that this will decrease because you have an increased normal force will cause a smoothing of the two surfaces. So sometimes this actually happens when you have a large force between objects, the stuff kind of smushes down and becomes more smooth. So you have a smaller normal force, but sometimes it actually increases. So you can imagine like concrete on concrete, it pushes the stuff further together and it pushes those little rough spots into each other and makes the coefficient go up. So you could have said remains the same, decrease or increase for coefficient of friction, and as long as you explained it well, you would get the point. So I just think that's funny that they're just like, any of these. But we're going to stick with normally that coefficient of static friction only depends on the two surfaces. So I would go with example 2. For the level of class we're in, we're just going to say coefficient of friction isn't changed unless we change the surfaces. The effects that we see on the other ones are going to be smaller unless you have like more extreme ranges where you have a lot more. More friction. So your force of friction will change, right? So we do end up having a bigger force of friction. And we'll see that. We have a bigger force of friction, which means we have a bigger applied force to move this thing, but we also have a bigger mass. So we see from this equation, we end up with a bigger applied force in order to overcome the force of friction, right? Both of these go up, but we also have a bigger mass. So I'm increasing the numerator and denominator. So you need more force, yes. You have a bigger frictional force, yes. But we also have a bigger mass, and that's going to end up canceling out. So it's not asking if your frictional force goes up. Our frictional force does go up, but that coefficient of friction does not change. All right. So that's the first one. Again, don't stress so much about the experimental design. Experimental design will not be on the AP test. But a lot of the other questions could show up. A lot of the derivations, the sketches, solving for values from an image. So those are still important. Even though we're not doing an experimental design, still take them seriously, especially the parts outside of that experimental design part. All right, let's look at the next one. I think I've asked you a question like this on a test before or on a quiz or something. I like this question, and it's a pretty good question, except for their wording on part of it. So this is one of the shorter questions, 7 points. On the previous AP test, I would give you 13 minutes for this one. On this AP test, you'll get 15 minutes. So any of the ones that say 13 minutes, feel free to give yourself 15 minutes because that's what it'll be like on the AP test. Yeah, on your mock test, I'll make one that's 25 minutes and one 15 minutes. And you'll just kind of have to hold yourself to that standard because there's nothing I can really do. I'm not in class. I can't tell you to stop. All right, so a physics class is asked to design low friction slide. Again, what does low friction mean? Oh wait, sorry, my chat stopped scrolling. I think they would accept something like that, Tam, where if you said the applied force has to be bigger and the normal force is bigger and those end up canceling out, I think they would take that point. Yeah, I would be really specific. I would say the force of friction changes and the other force. Well, no, the force of friction changes and the applied force changes. Yeah, so back to this one. Low friction, they're just pretty much saying no friction. A better way of stating that would have been negligible friction. So they should have said negligible friction, as I think would have been a lot more clear. So this slides, so they slide down this and it launches off the end of the table. This is kind of like what I would expect on this year's test, how we have here. What are we using as this goes down the ramp? What concept are we going to use as this goes down the ramp? Kinematics is going to be really hard to do when you have a curved ramp. So not kinematics, but we're probably using this changes height, picks up speed. We go from potential energy to kinetic energy. So we're probably talking about energy on here. We could also talk about momentum at the end. We could easily have a block here where there's momentum and a collision. This is going to launch off the table in a horizontal launch. That means 2D kinematics. So expect something like that on this year's AP test, where you have a lot of different concepts packed into one. And I can't state enough, the people who make the test questions are making it really sound like each part is going to be an individual part. So if you go through and you have no idea what A is talking about, it sounds like you might be able to answer B, C, and D. So skip through, look around. Each part sounds like it's going to be very separate. So if you can't answer one part, just move around. You might be able to answer the other ones. All right, so they slide and then they launch horizontally from the top of the tables. Teams 1 and 2 assemble the slides shown on identical blocks 1 and 2. They start with the same height, D above the tabletop. Team 2 got the short table. They're the special group. And that's lower than table 1's table. So to compensate for the table, they make this end here a little bit above the height of the table. So it leaves horizontally at the same height above the floor. So they both launch from the same height. Both blocks are released from rest at the top of their respective tables. Do they land the same distance from their respective tables? No. What's different about these that's changing them? No. And again, when it's asking you to select a box, make sure only select one of those, check yes or no if you really know your answer. If you don't know the answer, it might be better just to not check one and then just write what you know. So yeah, the ramp on table 2. So what's the big difference about the ramp on table 2? First of all, let's talk about what concept are we going to use. What are we going to use as the block is moving along that ramp? So if there's no friction along the ramp, what concept are we using while the block is on the ramp? Not K. Is that a lowercase or capital K? What do you mean by K? Well, we do have heights. We're trying to figure out how far these things launch, so we probably need to know how fast these things launch. So we could look at on the ramp, we do need to get the velocity at the end of the ramp. So on the ramp, we have the total mechanical energy being conserved. And we should probably actually write this out. We should probably say mechanical energy is conserved. So my mechanical energy is conserved. So I could look at ramp 1. Ramp 1. Let's not do it that way. Let's say ramp 1 has a greater change in height to the end of the table than ramp 2. Right? You can clearly see that. Block 1 goes down a much greater height than block 2. Well, I guess not much greater. But yeah, block 1 has a bigger change in height to the end of the table than block 2 is, right? Because block 1 starts all the way up at that top dash line and ends at the bottom dash line. Block 2 starts below that top dash line and ends up above the bottom of the table. So ramp 1 has a greater change in height. That means, so block 1 converts more gravitational potential energy to kinetic energy. And we really should write this out, to kinetic energy. All right, so block 1 converts more gravitational potential energy to kinetic energy. Therefore, block 1 launches from the table faster than block 2. Block 1 converts more than kinetic energy. I'd probably say than block 2. Right? Everyone sees how block 1 has more potential energy lost, so it has more kinetic energy gained. These are identical blocks. It actually wouldn't even matter if they're identical blocks. Remember the whole energy, both potential and kinetic energy have mass, so that's going to cancel out. So that it doesn't even matter if they had different masses. All right, so block 1 launches, not 4, from the table faster than block 2. All right, now we get to our horizontal launch part. We know they launch horizontally from the same height. We know block 1 launches faster than block 2. Therefore, block 1 travels further than block 2. All right, so let's see if I missed anything. There's a chance I missed something. So correct answer, no. If the wrong answer is selected, you can still earn partial credit. So for attempting to use conservation of energy to compare the two blocks. Now, this just says attempting to use conservation of energy. So if you did this all horribly wrong and you were talking about energies and conversion of energies, I would give you that point. So even if you like completely messed up on the types of energies or how energy is transferred, that doesn't matter. Or if you tried to use energy and you thought there was friction and you were trying to include the frictional like work done by friction, I would say you still were trying to use conservation of energy. So as long as you were talking about energies, I would give you that point. For explicitly or implicitly indicating the launch velocities are different, I explicitly said the launch velocities were different. I went and completely said block 1 launches from the table faster than block 2. An implicit way of saying they have different velocities, so implicitly indicating launch velocities are different, this would be saying that block 1 has more kinetic energy. So if you never said block 1 was going faster than block 2, but you said block 1 ends up with more kinetic energy than block 2, I would give you that point. In the future, though, I would try to be more specific. Not always do they say explicitly or implicitly. If they said for explicitly indicating launch velocities are different, you would not get that point for saying their kinetic energies are different. But because they said implicitly also or implicitly, as long as you got more or less kinetic energy on one, you're good. For stating or implying that the time to reach the ground is the same for both blocks, I actually didn't explicitly say that. So I actually really should have gone more into the horizontal launch. So you would need to say they fall from the same height, therefore they take the same amount of time to fall to the ground. So I would say I did implying that the time to reach the ground is the same, so they fall from the same height. I should have put a little bit more thought into that. So they launch horizontally from the same height. And then we can do time to drop is going to be the square root of 2h over g. So we could have actually gone through and got that equation, right? That all comes from the second equation. Final y position equals initial y position plus the initial y velocity times time plus 1/2 acceleration in the y direction times time squared. We land on the ground. We launch from a height h. We're not moving up or down initially. We have no initial y velocity plus 1/2. Acceleration is due to gravity negative g times time squared. can add this over. 1/2 g times squared equals height, because I added the negative over, multiply 2 divided by g, times squared is 2 times height divided by acceleration due to gravity. So I probably should have gone through and actually done this and talked about this. So times square root of 2 times height divided by acceleration due to gravity. They fall from the same height, both on Earth, so they fall for the same amount of time, which means they go the same distance. Because that horizontal distance traveled is just the x velocity times time in the air. So that last point I probably should have been more explicit about. It happens. All right. That is there. There's part 2. It's like couldn't find that for a second. You scroll down. It's Monday. In another experiment, teams 1 and 2 used tables and low friction slides with the same height. I guess the teacher finally came along and fixed the table. However, the 2 slides have different shapes as shown below. So block 1, block 2. So this one, the steep one, this one starts not so steep, then more steep. Both blocks are released from the top of their respective slides at the same time. Which block, if either, lands further from the respective tables? So which one lands further? Block 1, block 2, or they both land at the same distance? Again, if you're unsure, don't check something, but if you're pretty certain, then check one. Not block 1. Yeah, if you're not sure, I wouldn't check anything. I would just write answers. So don't just guess. It is going to be equal. So they are going to end up at the same distance. So again, we're talking about energy, right? 1 and 2 start at the same height. Should probably say start and end at the same height. That means that the change in gravitational potential energy for 1 equals a change in gravitational potential energy 2 on the ramp. Wow, I cannot write today. On the ramp. All right, so they change the same amount of energy. That means that the kinetic energy for block 1 equals the kinetic energy for block 2 at the bottom of the ramp. So block 1 and 2 launch from the ramp at the same speed. One and 2 launch horizontally from the same height. So they launch horizontally from the same height, therefore they spend the same amount of time in the air. So same speed, same time in the air. That means they go the same distance. So 1 and 2 travel the same horizontal distance. Yeah, sometimes I write on ramp intentionally instead of on the ramp, just to mess with people. I like on ramps though. I like what pre-cal is making you do with on ramps. It is really useful for physics. Ever since I started on ramps, physics questions have gotten a lot better. Y'all are a lot more intuitive about how things work. In the past, trying to get people to think about how math works, it was really bad. This year, a lot of times y'all are asking me questions about the math, or you see the result before I get to it. So I know y'all don't like on ramps, but it really is helpful for AP physics or just physics in general. So I love what on ramps is making y'all do. Yeah, pre-cal. I mean, that's kind of the point of on ramps is getting you to think about math, and that's kind of like the whole point of physics is making you think about math. So on, I mean, physics is just applied math, so it makes sense. All right, so let's see if I get the point. So correct answer, they land the same distance, and they didn't care if you got the right answer here or not. So if you selected the wrong one, it doesn't matter. So change in potential energy from release to launch is the same, and the launch velocities are the same. So they fall from the same heights. They have the same change in potential energy, and then they end up with the same speed that they launch at. Implicit or explicit? Again, explicit is where I stated same kinetic energy, so same speeds. Implicit would be same kinetic energy, and then they didn't care about the rest. So you could write a lot of things about same time in the air, so they go the same distance. They didn't get points for that. They just cared that you got same change of potential energy, so they launched at the same speed. All right, and then the last one, that was part B1, part B2. Which block hits the floor first? Again, if you don't know, select one. I'm going to say these aren't the same. They do hit at a different time. Which block hits the ground first, one or two? Just imagine you're on both of those slides. Which slide do you think you're going to get to the bottom of first, one or two? Let's look at your initial acceleration. Which ramp accelerates a greater first? So if we go here, what's our acceleration at this very beginning spot compared to the acceleration at this very beginning spot? Yeah, one is going to have a really big acceleration right here, right? So one has a really big initial acceleration. Now, if I were to put a line somewhere, if I were to say draw a line across here, what can I say about the speed at these certain heights? So if I choose a certain height, the speed will always be the same. So at this line, they're always going to be at rest. At this line, they're going to be at the same speed. At this middle line, they'll be at the same speed. But that doesn't mean they get to the same speed at the same time. So even though they're going to be at the same speed at any height, it doesn't mean they're going to spend the same amount of time getting to the same speed. This one can accelerate more slowly in order to get to the same speed at that height. This one can accelerate more rapidly. So which one of these is going to launch from the ramp first? One or two? One is going to launch from the ramp first. So that means block one is going to hit the ground first. So block one accelerates at a greater rate at the beginning of the ramp. So, yeah, and two. So if block one accelerates at a greater rate, block one reaches the maximum speed at the bottom of the ramp faster than two. So they end up all at the same speed. At any height I choose, these are always going to be at the same speed. But block one gets that higher speed more quickly than block two does. So this is more a question about acceleration than it is to actual speeds. So at any given height, they're at the same speed, but not at any given time. So they are all going to reach the same speed at the same heights, but block 1 is going to reach that speed faster than block 2 is. They spend the same time in the air. That's all just due to the time in the air is going to be the square root of 2h divided by acceleration due to gravity. So that means 1 hits the ground first. So again, just kind of looking at this. Same one too. Yeah, I mean, so on 1, if you selected 1, you can still get points. But yeah, so 1, it reaches the higher speed faster. 2 launches at the same speed at the end, but it takes more time to get over this hump. So it takes more time to reach that maximum speed. So that's going to take more time to hit the ground. And let's see. So correct answer, block 1. Again, you didn't have to get the correct answer. So no points for the correct answer. And again, even though it's not losing points for incorrect answers, just make sure if you know the answer selected, but make sure if you're selecting one of the answers, you know for sure that's the correct answer. You're a lot better off not selecting the answer if you're unsure. But I would say if you're like above 80% sure, I would select the correct answer. So if you're rather confident in your answer, select that one. All right, so indicating the average speed or velocity for higher for team 1. So I didn't go with the average velocity route. Or that block 1 reaches the maximum speed in less time. So I used the or statement. So block 1 reaches the maximum speed in less time. So block 1 has a bigger acceleration. It accelerates at a greater rate, so it reaches that maximum speed faster. Yeah, so for this one, if you gave the wrong answer and you gave a perfect explanation that contradicted with this, yeah, you would get the points. But the problem with is if you got the wrong answer, then you probably got the wrong explanation. So if you chose the same, then you probably aren't going to get points for the explanation. And then I didn't give the why, but yeah, or why block 1 reaches the maximum speed in less time. So why block 1 reaches the maximum speed in less time? That would be something like block 1 has a greater slope, so it has a greater acceleration, so it reaches the maximum speed in less time. And then the example response, because the ramp on table 1 is initially steeper, block 1 has a higher average speed. So again, I would change this with because the ramp on table 1 is initially steeper, the block reaches its maximum speed in less time, so it launches off the table before block 2. So when they go through and grade these, they calibrate. So all the graders get together and they grade like a few hundred initially tests, and they get to the point where they have the same idea of what they're going to give for points. So there's no flexibility on that. They've all gotten to the point where they know exactly what they're going to grade and how they're going to grade it. So no flexibility on that unless you give a non-standard answer. So normally they have alternative responses. So see how you could say this or this. So they kind of spell out what an alternate response looks like. And then very rarely they'll have like a second alternate or a third possible answer, where just a few people have gotten to that answer and they'll write it out. But the only time that there's flexibility is if you have like a really non-standard answer. And if you have a non-standard answer, then they have to get together with the lead grader and then go through and discuss whether they think that you should get the points. But those are a lot harder to get. So not a lot of flexibility on the grading key. Sometimes they grade them a little bit differently than what it looks on here. They decide what would be and what wouldn't be, and they go together and they have a board, and then they put up sample responses and they say why this one is and this one isn't. I don't think a dollar bill would persuade anyone, especially not a JPEG. You could be like that one guy that sold the Eiffel Tower a bunch of times. he had a fake money making machine that was like, oh yeah, this machine, you just press a button and it prints out $100 bills. And so what he did was he like just had like $200 or $300 bills in there, and like it was just set to a delay. So you press the button and it like makes some noise and delays, and then out pops $100 bill. So he would like put some money into the machine and put like a few $100s in there, but then he would sell it for like thousands of dollars. And so he tricked the people into thinking, oh, I'm just going to be getting continuously $100 bills. So he like invested like a few $100s and then got thousands of dollars out of people. Not that I'm suggesting you try to do that. Yeah, I mean that was the same guy that sold the Eiffel Tower like 3 or 4 times. I don't. Maybe it was like just 2 times. But yeah, I can't remember if it was him or someone else that sold the Brooklyn Bridge. But yeah. All right. Any last minute questions on this? So write up any last minute questions you have. Just kidding. I'm going to go through a few things. So yeah, we're about a month away from the AP test on May 14th. So we're just going to keep going through questions like that. Please keep trying to keep up, especially since I'm pretty much just giving you the answers. I can't stress enough how important it is to try to go through these. Try to limit yourself to the allotted time. Don't look at answers. Wait till you finish this, then look at the key and look at this video. Other things, if you have anyone in my class's phone number, I mean anyone, like not just your friends, just people you have any contact information with, please get out, just help me try to make sure they're turning in their work. If you know it's someone who doesn't work a lot, just tell them I can work with it if they turn in some work, but I can't work with it if they don't turn in any work. So just try to get them to turn in some things, especially tests. If you haven't turned in your spring break test or the other test or any labs, those are the things to really get in. The other thing, I am working on getting a mock test together, so that'll probably be out later in this week. I haven't decided on the exact day I'm going to put it in. But yeah, I'm going to try to make it similar to what it sounds like the actual AP test will be like this year. Other than that, have a good day. I'm going to stop the recording here. If you have any more questions, ask them now. Oh yeah, so that's the other thing. Last thing, the grading cycle. The grading cycle has been extended to this week. I don't know if they're going to keep doing this, but yeah, get your work turned in. You have until Friday to get it turned in at the moment. So if you have any late work, get that in by Friday. I don't know what they're doing, if the cycle is actually going to end. Officially, the 6th grading cycle opened up, but yeah, I don't have any word from the district on any of that. So if you have any late work, just keep getting that in. I can keep putting in grades for the 5th cycle until the end of this week. And then I guess they're going to start a 6th cycle. But yeah, so if you have any work, keep getting that in.